Use experience and wisdom to solve grinding problems. Welcome to Ingrid.
For grinding professionals, when you encounter issues like workpiece burning, grinding wheel clogging, inaccurate dimensions, or surface scratches during grinding operations, your first reaction is usually to adjust the grinding parameters. However, many people adjust the grinding wheel speed, feed rate, and depth of cut blindly all at once. Often, the problem is not solved, and you may even waste workpieces and damage the porous grinding wheel. Today, I want to clarify a core point for you. There is no fixed and unified priority for adjusting grinding parameters. It is likely not a fixed sequence of first adjusting the speed and then the feed rate. No matter what problem you encounter, when facing different grinding problems, it is recommended to adjust them according to the corresponding priority. Identify the root cause of the problem and prescribe the right medicine, which can often solve the problem quickly, avoid detours, and reduce cost waste. First, you may want to understand why there is no unified adjustment sequence, because the root cause of each grinding problem is different. Some are caused by excessive temperature leading to workpiece burning, some by poor chip evacuation resulting in grinding wheel clogging, some by improper stock control causing dimensional deviation, and others by excessive load leading to grinding wheel chipping. Since the core contradictions of the problems are different, the parameters to be adjusted first are naturally different. Our principle is, first solve the most core problem, then gradually optimize the auxiliary parameters, and try to avoid blind adjustment based on this principle. Next, I will explain the parameter adjustment priority corresponding to the 6 most common problems in the workshop, and you can refer to it. The first one, which is also relatively common, the workpiece is burned, turns blue, or even partially annealed. When encountering this situation, it is recommended not to adjust the feed rate and depth of cut first, but to prioritize adjusting the cooling settings. You can appropriately increase the coolant flow, adjust the nozzle position, and try to make the coolant act directly on the grinding zone. If it is a dry grinding scenario, it is recommended to switch to wet grinding first. Second, you can appropriately reduce the grinding wheel linear speed to reduce the heat generated by friction. Third, reduce the depth of cut, and finally slightly reduce the feed rate. Adjusting in this order can usually effectively improve the burning problem. The second type, the grinding wheel is clogged, chips stick to it, and it feels slippery and weak during grinding. For such problems, it is recommended to prioritize adjusting the grinding wheel linear speed. Increasing it appropriately can make the grinding wheel sharper and reduce chip adhesion. Second, adjust the feed rate to a suitable range, not too fast or too slow, to avoid chip accumulation on the grinding wheel surface. Third, you can reduce the depth of cut, and finally dress the grinding wheel in a timely manner to remove the adhered chips and dull abrasive grains on the surface. Generally, the cutting force of the grinding wheel can be restored. The third type, the workpiece dimensional deviation is large, and the geometric tolerance cannot meet the requirements. Such problems are relatively direct. It is recommended to prioritize adjusting the depth of cut. Especially during precision grinding, the single depth of cut should be as small as possible to accurately control the cutting stock. Second, adjust the feed rate to ensure a stable and uniform cutting process. The grinding wheel speed can be kept stable, and finally you can check the workpiece clamping and machine tool runout to rule out the impact of equipment and clamping. The fourth type, the workpiece surface finish is poor, with scratches, waviness, and the roughness cannot meet the specified standards. It is recommended to prioritize adjusting the grinding wheel linear speed. Increasing it appropriately can reduce the cutting marks left by the abrasive grains on the workpiece surface. Second, you can greatly reduce the feed rate, and slow grinding can improve the surface flatness. Third, reduce the single depth of cut, perform precision grinding several times, and finally dress the grinding wheel flat. Usually, the workpiece surface finish can be significantly improved. The fifth type, the grinding wheel wears to fast chips or even breaks. For such situations, it is recommended to prioritize reducing the depth of cut to reduce the load on the grinding wheel and avoid the abrasive grains from chipping due to hard contact. Second, appropriately reduce the grinding wheel linear speed to reduce the impact during the grinding process. Third, adjust the feed rate to maintain uniform feeding, and finally check whether the grinding wheel selection is appropriate. If the selection is improper, it is recommended to replace the grinding wheel in a timely manner. The sixth type, there is large vibration, high noise during grinding, and chatter marks appear on the workpiece surface. It is recommended to prioritize reducing the grinding wheel linear speed to reduce the vibration caused by high-speed operation. Second, reduce the depth of cut and feed rate at the same time to reduce the impact during the cutting process. Third, check the dynamic balance of the grinding wheel, redress the grinding wheel to make it flat, and finally check whether the workpiece is clamped firmly and whether the machine tool is loose. After mastering the adjustment priority for different problems, I will summarize 3 precautions for adjusting parameters to help you avoid mistakes and make parameter adjustment more efficient. First, before adjusting the parameters, it is recommended to check whether the grinding wheel is dull, whether the coolant is sufficient, and whether the workpiece is clamped firmly. First, rule out non-parameter problems, then adjust the parameters. Second, try to adjust only one parameter each time. After adjustment, observe the processing effect, then make the next adjustment. Avoid changing multiple parameters at the same time, which may make it impossible to determine which parameter actually works. Third, do not over-adjust parameters to solve one problem. For example, to prevent workpiece burning, setting the speed to low may lead to a significant drop in processing efficiency, which is not worth the gain. It is recommended to balance processing quality, efficiency, and grinding wheel wear. In general, the core of adjusting grinding parameters is to prescribe the right medicine. There is no fixed sequence. The key is to identify the core of the problem and adjust step by step according to the priority. To summarize briefly, for workpiece burning, you can prioritize adjusting cooling and speed. For grinding wheel clogging, prioritize adjusting speed and feed rate. For inaccurate dimensions, prioritize adjusting depth of cut. For poor finish, prioritize adjusting speed and feed rate. For excessive grinding wheel wear, prioritize adjusting depth of cut and speed. Adjusting according to such priority, you will not panic when encountering problems and can solve them quickly. At the same time, it can save grinding wheel consumption and reduce workpiece scrap. If you encounter any difficulties in parameter adjustment during daily processing, you can leave a message to communicate, and we will find a solution together.